All right, we're going to do a quick tutorial about the relationship between barometric pressure, air pressure, and wind speed within tropical cyclones. This graph just happens to be like Typhoon Samba or somebody like that. That was one in the Pacific Ocean. Down here on your x-axis are what? The dates. Okay. Over here on your left-hand side y-axis is the barometric pressure in hectopascals. That the unit is not super important to you guys. It's very similar to millibars, but again, the unit's not so important. Just know that you've got lower pressure down here, higher pressure up here. Okay, so that's the left-hand side of the y-axis. But we actually have two lines. So one of them we're going to be plotting barometric pressure as time goes by, and the other line, we're actually plotting wind speed as time goes by. And you might want to ask, why on earth would you put both graphs on the same piece of graph paper? Well, it's because we want to see what is happening to wind speed as barometric pressure changes, or what is happening to barometric pressure as wind speed changes. So we want them kind of both on the same graph so that we can look at them together. Okay, so the black line is your wind speed. The red line is your air pressure. Okay, there's a little arrow right here that says landfall. Y'all know, because we've talked about this, that once a tropical cyclone moves over land, it weakens. It gets weaker because it's cut off from its energy source, its main ingredient, which is warm ocean water. Okay? And that should make sense if you look at the wind speed. As soon as it makes landfall, the wind speeds start to go down. Okay? And by the way, pay attention. The wind speed is not in miles per hour. It's in a different unit. It's in meters per second. Don't worry so much about what that means in miles per hour. Just know that as soon as it makes landfall, the wind speeds start to drop. Okay, but let's go way back here to September the 11th, 2012. You have low wind speed and fairly high pressure. Wind speed starts to go up. The same time, the air pressure starts to go down. Wind speeds go up some more. Air pressure drops some more. Okay? What I want you to notice is that when you have really high wind speeds, you're going to have really low barometric pressure readings. Okay? When you have low wind speeds, you're going to have pretty high barometric pressure readings. So wind speed and pressure are they have an inverse relationship, which means when one of them increases, the other one actually decreases. Okay? So I want you to realize that, because that's a very important relationship. One of the big indicators of a very, very strong tropical cyclone is a really, really low barometric pressure. Now, barometric pressure is not used to categorize tropical cyclones. Only wind speed is used to categorize them. But barometric pressure is a very good indicator of the general strength of the storm as well. Okay? And when you've got high winds, you know that that's a strong storm. And high winds are also going to be associated with really low air pressures or barometric pressures. Okay? So I just want you guys to be familiar with that. Do not let something like this intimidate you just because there's a y-axis here that goes with one set of data and a second y-axis here that goes with a second set of data. It's just so that they could plot both of them on the same graph so that you can see how these two act with one another. Okay? Low wind speed, high pressure. High pressure, low wind speed. High wind speed, low pressure. Okay, so the two are inversely related. When one's big, the other one's small. Okay, that's what I want you to see. I wanted to show you this because, hint, hint, you'll probably see something similar to this at some point on an assessment. Okay?